Dear students, Assalamu alaikum. Hope that you will be enjoying uh, cities at your home, and I'm sure that you may not be wasting your precious time. And today I am with another topic that's friction for class 11th, and it's from laws of motion. About friction, you may have learned early in your earlier classes. Friction is an opposite force that comes into play when one body rolls or tends to roll slides or tends to slide over the surface of another body is called friction. For example, when we rub our hands, one hand slides over the other, that is called a sliding friction. Sometimes you may not be able to slide one hand over your another hand. You may try to slide your hand. That time, then we say that it tends to slide. So still, if it tends to slide, there is a sliding friction, or if it slides, then there is a sliding friction. Similarly, when a vehicle flies on a road, there is a friction between the road and the wheels of the vehicle, and that's called rolling friction. If the wheel is not able to roll, then that time we say that it tends to roll, and there is still a friction which is called a rolling friction. So if it rolls, actually it rolls, or if it tends to roll, if it tries to roll, in both the cases there is a rolling friction. Now, what is the cause of friction? There are so many views. Uh, there are so many views regarding this friction, regarding the cause of friction. According to old view, the force of friction arises when two bodies are in contact with each other. The irregularities in the surface of one body get interlocked in the irregularities of the other body. You may not be able to have a completely smooth body. If even the smoothest body may have some irregularities in it, so those irregularities get interlocked in each other, and that results in the force of friction. Now, according to modern view, the force of friction arises on account of the atomic or molecular force of attraction between the two surfaces at the point of actual contact. For example, when you put your one hand on your another hand, there are molecules in both the hands. They attract each other, and they do not allow one hand to move freely on the other hand. So there comes a force of into play. That force is known as force of friction. This is the modern view. By modern view says that this is force of attraction between the molecules of the two surfaces. And old view says that the irregularities in the two surfaces get interlocked in each other, which results in the force of friction. Now, friction may be divided or classified into two types, two kinds. One is internal friction, and the other is external friction. I am just going to give you some introduction about internal friction, and we are not going to discuss it in detail in this chapter. We will discuss only external friction. So let me tell you first what is internal friction. Since every body is made up of molecules, so the force between the molecules, the internal force between the molecules, when one molecule tries to slide over the another molecule, that force which comes into play is called internal friction. The potential internal movement can be due to either external force, some external force may be acting on the body, which results in the internal inside the body, the molecules try to tend to move or slide over the other, or it may be due to rise in temperature. If the temperature rises, that in that case the molecule may try to move over the surface of the other, or it may be due to deformation of the body. It is the static internal friction. Remember this thing between the particles that tries to keep them stationary and in place. Now let us start now discuss about this external friction, which will be our main focus. The external friction arises when two bodies in contact try to move over the surface of each other, or when there is an actual relative motion between the two surfaces. So if they try to move over the surface, one body tries to move over the surface of another body, there is a force of friction, and that force of friction is known as external friction. Or if it actually moves over the surface of another body, that is called external friction. The external friction is also called a contact friction. External friction is of three types. So external friction may not exist if the two bodies are not in contact. Once they are in contact with each other, then there is a force of friction that is known as external friction. So it is also known as contact friction. External friction is of three types: static friction, limiting friction, and kinetic friction. Let me first take static friction. Let us consider a body, consider a block, as you can see from the figure, which is placed on the smooth surface, say, or say table, horizontal surface. Let it may be a table. We have a small block by block, just as block, wooden block. It is just it may be just like a brick of the of which the houses are made. So it is a block. It is placed on horizontal surface, say table. Now what we see there are first, there are two types of forces. One force is the gravitational force or the gravity, which tries to bring it down to the surface of the earth. That is mg. Then there is another force. This force, gravitational force, we see that the table does not come downwards. So there might be another force which balances this force, which keeps it upwards. Otherwise the table will break. If there is no upward force, then the table will break and the block will come downwards. But there must be another force which balances this force mg. Now there is another force, that is p, which is the applied force. When we apply it, when we want to move it in the forward direction, that force is called, we need a force, that force is called applied force P. P is the applied force, and this applied force P is balanced by an opposing force that is known as friction. Frictional force that is denoted by F. So the weight mg, that is mg is the weight of the body which acts downwards, which tries to bring, weight is a force which tries to bring it downwards to the surface of the earth. But the table does not allow it to come down. The table, there must be another force which balances it, and this mg is balanced by normal reaction R. We are on the surface of the earth. If the earth under our feet is dug, we will come downwards. So there must be another, there is some force which keeps us up, that is normal reaction. So any surface on which a body is placed, there acts a force which keeps it up, that is called normal reaction. Now, so normal reaction is also a force which acts upwards. Weight is a force which acts downwards. Suppose that a small force P is applied on the block in the right direction. We want to take the block towards the right. The force of friction F opposes the applied force P. So long as the block does not move, P is balanced by F. If the block does not move, then remember that for applied force P is equal and opposite to the frictional force F. Therefore, F is equal to P. Now, if we increase the force, applied force, suppose we apply 10 Newton, the block does not move, then we apply 11 Newton, the block does not move, then 12 Newton, 13 Newton, 14 Newton. So we increase our force, but the block does not move. It means the force of friction also increases. When I applied the 10 Newton force, the force of friction was also 10 Newton. Then I applied 11 Newton force, the block did not move. It means the force of friction also increases from 10 to 11. Then 13, it also increases from increases up to 13. So if P is increased, F also increases and vice versa. F always remains equal to P. When your applied force is 10 Newton, the force of friction is also 10 Newton. When your applied force is 12 Newton, the force of friction is also 12 newtons. So F always remains equal to P. If you increase F, applied force P, the friction force F will also increase. So far the block does not move. We apply 10 Newton, 11 Newton, 12 Newton, 13 Newton, 14 Newton. Up to 14 Newton, say the block does not move. It is still there, so there is a force of friction. We increase our force, applied force P, the force of friction F also increases. The opposing force, that is P, that comes into play when one body tends to move, because the body has not yet moved, where it has just tried to move. When the one body tends to move over the surface of the other body, but the actual motion has yet not started, is called static friction. Now, what is limiting friction? Now, again, if the applied force on the block is further increased, say from it is increased beyond 14 Newton. Now the body starts to move. Up to 13 Newton, the body did not move. Now when I again increase the force from 13 Newton to 14 Newton, now the body starts moving. The stage comes when the body is just at the verge of moving over the other. The static friction at this stage is maximum. The maximum opposing force that comes into play when one body is just at the verge of moving over the surface of the other body is called the limiting friction. Limit. Now kinetic friction. Now if the applied force on the block is further increased, in first case, in static friction, the body did not move at all. In the limiting friction, now the body is at the verge of, means we just need a little bit of force, which will be applied on the body, and the body will start moving now. So it is at the verge of moving. If the applied force on the block is further increased beyond the limiting friction, the actual motion starts and the applied force P is greater than the limiting friction F. Now, you say if the limiting friction is 14 Newton, the body is just at the verge of moving. Now, if the force of friction is again 14 Newton. So 14 Newton is called the limiting friction. But when we increase the applied force from 14 to say 15 Newton, but the limit this force of friction it remains 14 Newton. It does not increase further. Then we increase our applied force from 15 to 16. The friction force just remains 14. It is not. So in kinetic friction, when the body is moving on the surface of the other body, that time the friction is known as, the friction which comes into play is known as kinetic friction. The opposing force that comes into play when one body is actively moving over the surface of the other body is called the kinetic or dynamic friction. It is also known as dynamic friction. So dynamic friction is always greater than the limiting friction. Now there are laws of limiting friction. Laws of limiting friction. First law, the magnitude of the force of limiting friction. Limiting friction. Remember this, I am talking about limiting friction. The magnitude of the force of limiting friction F between any two bodies in contact is directly proportional to the normal reaction R. It is directly proportional to the normal reaction R. That is, F is directly proportional to R. But we know that R is equal to mg, that is weight of the body. So greater the weight of the body, greater will be the limiting friction, force of limiting friction. Because F is directly proportional to R, which means F is directly proportional to mg, that is F is directly proportional to weight of the body. Greater the weight of the body, greater will be the force of limiting friction. This is first law. Now second law, the direction of the force of limiting friction is always, the direction of the force of limiting friction is always opposite to the direction in which the one body is at the verge of moving over the other. For example, if the body is at the verge of moving towards the right side, then the force of limiting friction will be towards the left side. So this is the second law. The first law is F is directly proportional normal direction R, and the second law is the force of limiting friction is always opposite to the direction in which the body is at the verge of moving. Now third law, the force of limiting friction F is independent of the apparent area of contact. For example, let us take an example of our hands. So the force of contact between our hands and the force of friction between our hands and the force of friction between the hands of a small kid will be same, because the apparent area of contact between our hands is much greater than the apparent area between the hands of the kid. But I tell you that the force of friction in both the cases will be same. The force of limited friction in both the cases will be same, because it does not depend upon the area of contact. It is independent of the area of contact. The force of limited friction F depends upon the material and nature of the surfaces in contact. First, it depends upon the material of, for example, the force of friction between the wood surface of wood and the force of friction between the surface of two metals will be different. The force of limited friction. If the area of contact is same or different, because it is independent of the area, but it depends upon the material in contact. Similarly, if you have two surfaces of metals in contact, but one of then we take the again the same metals and we put a grease in between them, between them, then we will see that the force of limiting friction will be less, will decrease. So this is called the nature of surface in contact. The first case is the force of friction between the surface of wood and the force of friction between the surface of two metals will not be same, because it depends upon the material. It depends upon the material of the surface in contact. Then another case is if one boy has two metals and he wants to find the force of friction between them, then another boy has the same metal surfaces in his hand and he wants to find the force of friction with, but what he does, he just puts the grease, some kind of lubricant between the surfaces, and you will see that the force of friction will not be same, though the surfaces in contact are same, but the nature of the surfaces in contact is not same. So tomorrow inshallah we will discuss coefficient of friction.